Okay, Chapter 7, Lesson 4 and 5 are going to be combined. They are about rationalizing the denominator. So up until now, we have let us leave the square root in the denominator, and today we're going to talk about why we can't do that. To simplify it, we're going to be multiplying, but we are also going to be talking in this section, because it also is Lesson 4, about adding and subtracting like radicals. So in adding and subtracting like radicals, as long as you have the same radical, so like they're both square roots or they're both cube roots, we can add or subtract just like variables. So in the past, we've always said that 2x plus 3x would equal 5x. We're going to do the same thing here. So if I had 2 square root of x plus 3 square root of x, it would be 5 square root of x. So number 1 here, I have the 4 times the square root of 11 plus 8 times the square root of 11. So I'm going to add my coefficients to be 12 square root of 11. And just like when we're adding variables, how we don't change the variable, we're doing the same thing with the roots. So these are kind of like our variables. So that will not change, only the coefficients. So this one says 5 cube roots of 3x minus 7 cube roots of 3x. So 5 minus 7 is negative 2 cube root 3x. This next one says 4 square root of 5 plus 4 cube root of 5 cannot be done. Why? And it's because this one is a square root and this one is a cube root. So they are not like radicals. So sometimes in order to add or subtract, we need to first simplify our roots. So I have the square root of 20, which I know breaks up into 4 times 5, plus 2 square root of 45, which I know breaks up into 9 times 5. The 4 here will come out as a 2, and I'll circle the 5. The 9 comes out as 3, and I'll circle the 5. And then I'm going to do 2 times 3 because there's no symbol, so I know that it implies multiplication. Now they are like radicals, so I can do 2 plus 6 is 8, square root of 5. The next one starts with the cube root of 54, which is not a perfect cube, but it breaks up into 27 times 2, minus the cube root of 16, which is 8 times 2, plus 3 cube root of 2. The 27 comes out as a 3, circle the 2, so 3 cube root of 2. The 8 comes out as 2, and circle this 2, and then multiply to be negative 10 cube root of 2. And the final one is just 3 cube root of 2. Now all of my variables are the same, so I'm going to do 3 minus 10 plus 3 would get me back to negative 4 cube root of 2. This last one, I have 27 square root of 27x, which I know breaks up into 9 times 3, minus 2 square root of 9x, plus square root of, and 72 breaks up into 36 times 2x. So this 9 comes out as a 3 square root of 3x, minus this 9 comes out of 3, which would be 6 square root of x, plus 36 comes out as 6 square root of 2x. Now this one cannot be simplified because none of the roots are the same, so that would just be the answer. Okay, now we're going to talk about rationalizing the denominators. So whenever I multiply a root by itself the appropriate amount of times, the roots will cancel out. So if I typed in the square root of 9 times the square root of 9, that would become the square root of 81, which I know goes back to 9. If I do the cube root of 2 times the cube root of 2 times a third cube root of 2, that would get me to the cube root of 8, which that one would break out into 2. So if I did the fourth root of 3, I would have to have 4 of them to become the fourth root of 3 times 3 times 3 times 3, which is 81, which then would come out as 3. So you have to multiply the root by itself in order to get the same number of multiplying roots as your number in the root to get them to cancel out. I want these erased. So we're going to be following that process here when we are trying to get rid of these square roots. So I have the square root of 20x over 9 plus the square root of 5x over the square root of 9. So I'm going to multiply this one by the square root of 9 on top and bottom, because that will get these on the left or on the right to become just a 9. Now on the left one, the 20, I know I want to break up into 4 times 5x over 9 plus, and I'm going to leave this one as 9 times 5x over 9. Now this 4 comes out as a 2, square root of 5x over 9 plus 3 square root of 5x over 9 becomes 5 square root of 5x over 9. The next one is 3x, square root of 7 over 5 plus square root of 7x squared over square root of 100. Now this one is a little bit more simple because it's a little more difficult, because I'm going to have to multiply both fractions to get like denominators. So to get rid of this, I'm going to times it by the square root of 100. But then I know that this is going to come out to be 100 down here. So what I'm also going to want to do to get like denominators is multiply this one by 20. So it becomes 60x square root of 7 over 100 plus 100 times 7x squared over 100. So now they have like denominators. Then this 100 will come out as 10, circle the 7. This x will come out as x to the first. So now I have 60x square root of 7 over 100 plus 10x square root of 7 over 100 equals 70x square root of 7 over 100, which the 70 over 100 then, those can both reduce by 10. So it becomes 7x square root of 7 over 10. Next, we're going to be simplifying like radicals with distributing and FOIL. So this first one, when I distribute, I make sure they're all like radicals, which they're all square roots. So then I do the square root of 5 times 15 becomes the square root of 45. And the square root of 5 times 35 is 175. 45 breaks up into 9 and 5. And 175 breaks up into 25 and 7, right? Yep. Which the 9 comes out as 3, square root of 5, and the 25 comes out as 5, square root of 7. Not like terms, so that would be my final answer. On number 2, 8 times 4 would give me 32, and then square root of y times the square root of y would give me just y, because they cancel out, remember. Square root of y squared, which is just y. Then I'll have 8 squared of y times negative 1 is negative 8 squared of y. Z times 4 would be plus 4z squared of y. And z times negative 1 is minus 1z. No like terms, so we leave them as they are. On this last one, we have square root of 5x times square root of 5x, which would be, remember the math on it, 5x, which would be square root of 25x squared, which is why it comes back out just as 5x. So don't forget that. And then I have these two multiplied would be negative 3 square root of 15x squared, which would actually be negative 3x square root of 15. Then down here, I would have negative 2 square root of 15x squared, which the x squared would come out as 2x. And then final negative 2 times negative 3 is positive 6. And then 3x square root of 3x times square root of 3x would come out as 3x, which is really 18x. So for my final answer, I'm going to combine like terms. So I have 5x plus 18x, which is 23x. And then negative 3x and negative 2x, both square roots of 15, can be combined to negative 5x, square root of 15. Okay, and this one says that we cannot leave square roots in the bottom of our fractions. So based on what we've been doing previously, to get it out of the bottom, I would just multiply it by itself. So then we'll have the square root of, or 2 square root of 5, and square root of 5 times the square root of 5 comes out as just 5. And then 2 and 5 do not reduce, so that's the final answer. The next one I have is 2 square root of 16 over the square root of 9x. Multiply it by the square root of 9x so that the bottoms cancel out and just becomes 9x. 16 comes out as 4. 9 comes out as 3. Circle the x. 2 times 4 times 3 is 24. Square root of x. In this case, 24 and 9 can reduce. The x's cannot because this one is inside the root and this one is not. So I just simplify the 24 and the 9 both by 3. So it becomes 8 square root of x over 3x. And that is the most simplified. The last room is the cube root of 1 over the cube root of 2. Now, to get rid of the cube root, I have to make sure that there are 3 total of those. So that one, again, would become the cube root of 8, which is just 2. And the top would become the cube root of 1 times 2 times 2, which is 4. And the cube root of 4 does not simplify. The next one is the square root of 7x over the square root of 3y. So multiply it again to get rid of the roots on the bottom. And then the top would become 21xy, which doesn't reduce by anything. Next one, the cube root of z squared over the cube root of 27x to the 4th. So again, make sure that there are a total of 3 of these because it is a cube root. Whatever you do to the bottom, you must also do to the top. So the bottom becomes just 27x to the 4th. And the top becomes the cube root of 27 times 27. Well, they can both come out. This can come out, right? Cube root, yeah. As a 3. This can come out as a 3. And also we're going to have x to the 8th total. So I'm going to have 9. 3 times 3 is 9. Cube root of x6, x2, z2, which comes out as x squared. So I have 9x squared, cube root of x2, z2, over 27x4. 9 over 27 becomes 1 over 3. x2 over x4 becomes x2 in the bottom. And then cube root of x2, z2. Okay, next is rationalizing binomial denominators. So what we are going to use is called the conjugate base. So the conjugate of a binomial is the same binomial or the same 2 terms, but a different sign in between them. So that when we FOIL, we can get our middle terms to cancel out. And then with the square roots canceling out also, we're going to be left with just x and a number. So in this case, I have 3 over 4 plus 4 square root of 5. So this is my binomial, and I can't just multiply by the square root of 5 because then I would have to distribute to the 4 in front and to the other one, and it wouldn't work that way. So what I need to do is multiply by the conjugate base, which would be 4 minus 4 square root of 5. Whatever you do to the bottom, you must do to the top. Now, the nice thing about this is because this one is all numbers, I'll show you the math on it, but you're going to find out we can just put it into our calculator. But if I do the FOIL, I would do 4 times 4, which is 16, and then 4 times negative 4 square root of 5, which would give me negative 16 square root of 5. Then the 2 positive 4s, square root of 5, would give me positive 16. And then this last one would be negative 16 square root of 25, which is really just negative 16 times 5. So these cancel out, and I have 16 minus 16 times 5, which is 80. And so 16 minus 80 is negative 64. Now, like I said, what's nice about the fact that these are all numbers on the bottom here is that you could just put that into your calculator and it would give you negative 64. Now, the top is not going to work so well because we have this only one square root here, so we know they're not going to cancel out. So I'm going to have 12 minus 12 square root of 5. Now I look at all those coefficients, and 12 over 64, what would it reduce to? So it's going to become 3 minus 3 square root of 5 over negative 16. So again, on this one, because it's all, we're multiplying square roots to get rid of them, and because it's all numbers, I can just put that one in my calculator, making sure that I change it to the conjugate base, which is why I'm doing negative 5 plus the square root of 3 square root of 3. So I have negative 5 minus 3 square root of 3 times negative 5 plus 3 square root of 3 gives me negative 2 for my base. Then this top will become negative 25 plus 15 square root of 3. And 25, 15, and negative 2 will not reduce. So on this one, I'm going to multiply by negative 3 plus 3 cube root of 3 plus 3 cube root of 3. So I have negative 3 minus 3 square root of 3 times negative 3 plus 3 square root of 3 gives me negative 18. That would give me negative 15 plus 15 square root of 3, which the 15s and the 18s can all reduce by negative 3. So that would give me 5 minus 5 square root of 3 over 6. And the last one, square root of 2 plus 5 square root of 3, square root of 2 plus 5 square root of 3, square root of 2 minus 5 square root of 3 times negative 2 plus negative square root of 2 plus 5 square root of 3. Negative 73 over 4 square root of 2 plus 20 square root of 3.